Okay, so this is lesson 6.3, and it is long dividing polynomials. So it sounds like kind of a nightmare, right? Like actual long division. Let's review long division back when you were a little lad or lass. So back when you were a little laddie or lassie, you did a little long division. Maybe like, let's go 11 divided by, I don't know, 2,156. Okay, like this is what I'm talking about here. 11, so 2,156 divided by 11. How do you do that? What did you do? Does anybody remember how to do this? Yeah. How many times does 11 go into 2, right? None. How many times does 11 go into 21? One time, okay? And then the next step was to take the 1 times the 11 and subtract it. Remember this? And so then what's left is 10, and that's not enough. So then you bring down the next number 5, and then you start over again. How many 11s go into 105? 9. Okay, if it was 10, that would be a problem. 9 times 11 is 99. Subtract it, you get 6. Bring down the next number, 6. Carson, have you done this before? The same algorithm? Yeah? What's that? Oh, nice. No calculators. Good. And then 11 times 66 is 6, and 6 times 11 is... Oh, and guess what? This one goes right in there perfect with 0 as the remainder. Wow, that was neat, huh? 0 as a remainder. It went in perfect, evenly. That's a beautiful thing. Okay. So now we're going to transition into long division of polynomials. You just saw how you remember how to long divide just numbers. Now we're going to long divide polynomials. Okay. All right. You want to say anything into the mic?
Hello.
Good. So here we go. Same process, but with polynomials. So what we're going to do is we're going to put the x minus 3 out here. And then inside the box, we have x squared plus 5x minus 28. Okay. A little bit different thinking now when we decide, like, it's kind of tricky to say, oh, how many x minus 3's go into, and it's just a little different thinking. So the way we think about this is, what do we multiply this x by for it to equal x squared? X, good. So that's what goes here. Okay, and then the process is the same as with numbers. You take that x times the x minus 3 and subtract. So once you take the x times the x minus 3, it's going to end up being a binomial. So you're going to subtract that binomial. X times x minus 3 is x squared minus 3x. So we're going to subtract x squared minus 3x from that polynomial above. Now, one of the big mistakes in algebra is if you're subtracting a thing in parentheses, you have to remember to subtract both of these terms, which means that both of these are going to change signs. So I'm going to distribute that negative here, and it's going to be a negative x squared and a positive 3x. So now I go ahead and subtract x squared minus x squared, those are gone, and 5x plus 3x is 8x. Bring down the 28, and the process then starts over again, it repeats. What times x is 8x? 8. That's what goes up here. I multiply 8 times x minus 3, and I subtract that binomial. So what is 8 times x minus 3? 8x minus 24. Distribute the negative, which changes both the signs. Combine those two together, x's cancel out. What's that? What? 8 times 3? So this is a negative 4. Now what times x gives me negative 4? Well, this is where we stop, right? Negative 4 is our remainder. So our remainder is negative 4 x minus thirds, or over x minus 3. Who votes that that was pretty slick? Let's see out there. 1, 2, 3. 3. 3.5. You're confused? Okay. Well, like if you factored x squared plus 5x minus 28, does that factor?
Wait, why
is that going to factor? 14 and 2, 4 and 7. I don't know if it's going to factor, and certainly it doesn't factor. It doesn't factor into anything like this, x minus 3 times some nice, neat, perfect binomial. Like there's no binomial here that you're going to multiply by to get it to factor. In fact, what goes there is this, is that stuff. So x minus 3 times x plus 8 minus 4 over x minus 3 is going to equal x squared plus 5x minus 28. It just doesn't divide in evenly.
Why are you switching like the negatives to positives?
Because you're subtracting the whole thing, you know. So you have to subtract both terms. Why did I put the 8 on top? Which 8? This one? This 8? Because what times x right here gave me 8x, and that was just the next like iteration in the process.
Okay.
Let's do it again. Okay, try again. So 3x plus 1, and inside the box we have 15x squared plus 8x minus 12. Okay, this starts out, what times 3x will be 15x squared? So 5x goes here, right? And then I'm going to multiply that by 3x plus 1 and subtract it from what we have. So 5x times 3x plus 1 is 15x squared plus 5x. And this is the part where you were like kind of unsure of, right? Is why does this minus, like why did that change or something? Well, we're minusing this whole binomial, so the minus has to go here and it also has to go there, right? So when I subtract, I take 15x squared minus 15x squared and 8x minus 5x. So I'm left with a total of 3x's. Now this was your question. Where did that 3 come from up top? Well, this is where the process starts over again. Okay, bring down the 12, negative 12, and then this starts all over again. What times 3x gives you 3x? That would be 1. So this is a plus 1. Multiply the 1 by 3x plus 1 and subtract it. Don't forget to distribute that negative when you subtract. So this is really a negative 3x and a negative 1. Clean that up. Negative 12 minus 1 is negative 13. So that looks to be your remainder. If it goes in evenly, what would the remainder be? 0, right? If it divides evenly, the remainder is 0. Neither one of these did that. The last little bit I want to show you is when you're missing some terms. So in this example, you have x to the 4th and then it goes straight to negative 5x. And so just like when we divide numbers, like let's just say we're dividing numbers. Let's say we needed to divide like 1052. And we wanted to divide that by like 10 or something. Well, I have to put that 0 right here for the hundreds place, correct? If I don't, then it's going to screw everything up, right? Like 1052 has a 0 right there. It's not just 152, is it? Is this number 1052? No, it's 152. So I have to put zeros in place of each place value, like ones, hundreds, whatever. So that's the same thing here. Like I'm missing an x cubed term, so I need to put 0x cubed, and I'm missing an x squared term, and I need to put 0x squared. Otherwise, everything's going to get all messed up. It's not going to work.